Hello, my name is Jinyang. I'm going to present our paper, Denouncer Detection of Unfairness in Classifiers. Nowadays, machine learning models are widely used as decision-making tools in many domains. For example, we use them to decide whether to grant a loan, whether to hire a candidate, and even whether to parole convicted criminals. At the same time, however, we also witness a large number of cases where these tools are biased. For instance, ProPublica conducted a study on campus and showed that the software discriminated based on race. Black criminals were scored at a higher risk of reoffending than the actual reoffending rates, and it's the opposite for the white. Another example is an article published in the New York Times about the International Baccalaureate test. Due to the COVID-19 pandemic, the final exams were canceled and students got computer-assigned grades. As a result, some students from low-income families were predicted to fail the Spanish exam, even when they are native Spanish speakers. There are some challenges to study the issue of algorithmic fairness. First of all, there are many fairness definitions proposed and used in different cases, including overall accuracy, false positive error rate, and so on. Different definitions can lead to different results. In the ProPublica example, when we consider false positive rates, blacks are treated unfairly, but when we consider false negative rates, the white should be reported. Fairness definitions usually refer to a given protected group in the data, but the group definition can be unknown in advance. As in the New York Times example, part of the bias comes from historical IB test results of the school, but it's not natural to use the school ID to define a protected group. Here we introduce some terms that will be used in our demonstration. We use a pattern to define a group, which is a set of attributes with assigned values. And we want to detect large enough groups whose degree of unfairness is also large enough. So here we have two thresholds. We use a size threshold to define how large a group should be. And we also have fairness delta. For example, the false positive error rate of campus is 0.32. We set the fairness delta to be 0.1 so that we want to detect groups whose false positive error rate is larger than 0.42. Our system allows users to set all the parameters by themselves. And this is the user interface of our system. First of all, the user needs to select a data set. There are 3 different data sets provided by the system. Or the user can also upload their own data set from local computer. And then the user can preview the data. For example, this table here shows the content of campus dataset. And the user can select attributes they are interested in. We want to reproduce the results by ProPublica, so we select the attributes the same way as they did. Sex, age, and race, submit. And then the user needs to select or upload their own machine learning classifier. And here the system provides some different fairness definitions. For instance, we choose false positive error rate. And this number here shows the false positive error rate of campus data is 0.32. Here the user can set their own thresholds. For example, we set the size threshold to be 20 and fairness delta to be 0.1. And we get 2 patterns. African American, which is consistent with the results by ProPublica. And we also get a new group, which means people younger than 25. When we change to a different threshold, we may get different results. And if we select a different definition, for instance, false negative error rate, this number can be different. And we also get a new result. The third pattern, Caucasian, is also consistent with ProPublica, which means white people have higher false negative error rate. That's all for our demonstration. For more details, please refer to the paper. Thank you for your attention.